Hello, my name is Mary Jo Fender, and this is Math for Middle School. Today we're going to be going over quotient of powers. What you'll need today is paper and pencil. Okay, take a quick second, let's get ready to learn. Our goal today is to use laws of exponents to divide monomials. Now, if you remember last week, we were talking about product of powers. Product means multiplication. This week we're going to be talking about quotient. Notice product and quotient are opposites, so that might give you a hint on the process we're going to use today. Let's take a look at a couple examples from last week's lesson. You'll notice my first example is x to the m times x to the n. And our laws of exponents say if our bases are the same, and our bases here are the same because they are the base of x, I can add my two exponents together. So I would add m and n, whatever those happen to be, and I would get my product of my power answer. So let's stick some numbers in there and see if we can come up with some product of powers. So 12 to the fourth power times 12 to the third power. Remember, our bases are the same, they're 12. So all we're going to do is add our exponents together, which is 4 plus 3, which gives us a final product of 12 to the fourth power. So remember, product, quotient, they're opposite. Adding, what's the opposite of addition? So let's take a closer look at a quotient of a power. So simplify, remember, just means to write in simplest term. So we have 3 to the 6th divided by 3 to the second. And if we take a look and expand these out, I'm going to say 3 times 3 times 3 times 3 times 3 times 3. I'm going to put my fraction bar. Remember, fraction is our term or our symbol for division. And we're going to expand 3 to the second power, 3 times 3. Now, if you remember your work in fractions, anything over itself, so a over a, or a divided by a, is always equal to 1. Now, you'll notice that we have two groups of 3. 3 is in the numerator and in the denominator position. So we can break those apart from the group and say those particular groups are equal to 1. So I'm going to just draw a big number 1 through them. In algebra, we say that it cancels, and most teachers just slash it out or ignore it and move on. So if you'll notice, I have 4 3's left. You'll also notice that they're on the numerator's position, and that's going to become a factor in later work with exponents. So that's going to be 3 to the fourth power. In our denominator, we have 1 times 1, which is 1. So our answer is 3 to the fourth power over 1, or 3 to the fourth power to the first. Now, when we talk about fractions, anything over 1 is a whole number, and it can be rewritten. And so when we rewrite this, it would be 3 to the fourth power. So our question, 3 to the 6th divided by 3 to the second, in its simplest form, is going to be 3 to the fourth. Now, did you notice a trick? When we talked about products, we would add the exponents. Notice here, if we do 3 to the 6th, what's the opposite of addition? Oh, yep, it's subtraction. And we subtract our exponents, 6 and 2. We're going to end up with 4. Keep our base of 3, use our exponent of 4. Our answer is 3 to the fourth. Notice that this is the same as if we did it in expanded form and canceled. That's a quick shortcut, especially when you get good at it. It will save you a lot of time. So let's take a look at another one. Notice we have 2 to the 8th divided by 2 to the 5th. The first thing we have to check is our bases. Do we have the same base? Yes, we do. The base is 2. Because our base is 2, we can, remember what's the opposite of adding? Yep, subtracting. We're going to subtract our 8 and our 5, our exponents. So 8 minus 5 is 3. So 2 to the 8th divided by 2 to the 5th in simplest form is 2 to the 3rd. Okay, so let's try another one. This time, we're not going to have a base that's a number. We're going to use a variable. So we're going to simplify x to the 9th divided by x to the 4th. Remember, the very first thing we have to check is, does the powers have the same base? And this time, our base on both of our powers is x. So yes, it is. And now we can apply our laws of exponents. So remember, anytime we're dividing, we can actually subtract our powers and come up with the same answer as if we wrote it in expanded form. So if we said x to the 4th power, x to the 9th power minus 4. You're going to ask yourself, okay, what's 9 minus 4? That's 5. We're going to keep our base, x. Our exponent now becomes 5 because we have 5 extra variables, which are x, in the numerator's position. We don't need to write the 1 underneath when we do this because it's already in simplified form. So let's try another one. This time we're going to use coefficients with our exponents. And basically when we do this, we have 2 separate problems. We have to break our coefficients out, and then we have to work with our powers. So our first problem is 15 over 5, or 15/5. You can say 15 divided by 5 if you want. You need to simplify those coefficients. Now sometimes they'll simplify, sometimes they won't, sometimes they'll turn into whole numbers. You need to be expecting anything. But you should be thinking to yourself right now, oh, I know what 15 divided by 5 is. 15 divided by 5 is 3. So our coefficient for this particular problem is going to be 3. Do we have the same bases on our powers? Absolutely, we have the base of y. So we're going to say y to the 7th power minus 3. Remember, we're going to subtract our exponents. That's our shortcut. And what is 7 minus 4? Or I'm sorry, gave you the answer. 7 minus 3, that's 4. So our power is y to the 4th. Now to make our final answer, we're going to take our answer from our coefficients. We're going to take our answer from our power, and we're going to put them together. So our final simplified form of 15y to the 7th divided by 5y to the 3rd is 3y to the 4th. Remember, when you're working with exponents, you have to break them apart. So let's try another one. Notice we have 7x to the 6th divided by 9x to the 2nd. Break your coefficients off. Can you simplify 7/9? I hope you said no, because it is already in simplest form. Now let's break our powers off. So if we have x to the 6th divided by x to the 2nd, do we have the same bases? Yeah. So all we have to do is subtract our exponents. 6 minus 2, yep, that's 4. We're going to put our 2 sets of answers together. So our simplified form is 7/9 times x to the 4th. Now you may see some teachers, because x to the 4th is actually a whole number, keep it in the numerator's position. So you could actually say 7x to the 4th divided by 9. And it's the same thing, it just looks a little differently. Let's try another one. This time we have 28 into the 11th divided by 18 into the 3rd. Break your coefficients out. 28 over 18. What does that simplify to? Okay, you can divide both by 2. 28 divided by 2 is 14, and 18 divided by 2 is 9. Now we can keep this just like this as an improper fraction, or we can actually write it as a whole number. We can say 1 5/9. Now how I got that answer is I know 9 is going to go into 14 one time. That makes a whole. I have 5 left over, so that's my 5/9. Now I'm going to do my powers, so I'm going to say n to the 11th divided by n to the 3rd. Check my bases. Are they the same? Absolutely. So I can use my laws of exponents and say 11 minus 3. 11 minus 3 is 8. So my answer is n to the 8. Put your two forms together. Now this one you can write in a couple of different ways. You can say 14/9 n to the 8th, or you can say 1 5/9 n to the 8th, or remember n to the 8th is really a whole number, and I can write that as n to the 8th over 1. I can actually say 14 n to the 8th divided by 9. It all depends on what you're going to do with this, on how you're going to write this. So let's try one more. I have 36x to the 12th divided by 9x to the 8th. Remember, break your coefficients apart. 36 over 9. What does that simplify to? I hope you notice that 36 can be divided by 9 evenly. That gives us 4. And x to the 12th divided by x to the 8th. Do we have variables that are the same as our bases? Absolutely. So we can say x to the 12th divided by 8. What does that equal? 4. So we can say x to the 4th. Now, all we have to do is put our coefficient and our power together. So our answer is 4x to the 4th. Now it's your turn. I have 3 practice problems for you to do today. That concludes our lesson for today. So let's take a quick review. Remember quotient of powers. We need to subtract the exponents as long as we have the same bases. If you have coefficients, break those out first. Simplify as far as you can. Then work with your powers. Get that in simplest form and then put your two together. Thank you for joining me today. It's been my pleasure having you in class. My name is Mary Jo Fender, and I'll see you next week.